A special situation where we have an acid and a base is called, when you have an acid-base reaction, you can carry out something called a titration. You'll be doing a titration lab. A titration lab setup looks like this diagram I have here, where you have the burette, this long cylindrical piece of glassware, and in the burette it is filled with sodium hydroxide, or a base, and a typical titration is a strong base. And at the bottom, there's an Erlenmeyer flask, see? And in the flask, it's where you put your acid. And we're going to put hydrochloric acid in the flask. And what we would do is we would measure out exactly, precisely, a certain amount of hydrochloric acid. And so we're going to put exactly 10 milliliters of hydrochloric acid in this flask. And we're going to start in this burette. If you look closely up here, that's where the level is starting. Okay? So, let's pretend that we are starting with the level of the burette at 48.60 milliliters. And what we would do is open this stopcock, and we would slowly let the base drip into our acid. Now, what's going to happen? What we've done is we have added an acid-base indicator to this flask. And the indicator you use for this particular titration is called phenolphthalein. And what phenolphthalein does is an acid. Right now it's colorless. But we are slowly going to add sodium hydroxide to this solution. And when we've added enough sodium hydroxide so that these two have reacted perfectly and we've used up all the acid, this solution in the Erlenmeyer flask will turn pink. So, we have opened the stopcock and we've slowly started to add the sodium hydroxide. And then at a certain point in this titration, the solution in this Erlenmeyer flask would turn pink. Okay? And that's a really lame representation of what happened. There's some other pictures in your textbook that you can look at. But when the solution turns pink, we, of course, turn off our stopcock, and we note at what level our burette has drained down to. So we will say that this burette drained all the way down to 12.40 milliliters. So if we started at 48.60 and we ended at 12.4, we can subtract these and see exactly how much of the base we added. And when I subtract these, I'll see that I added 36.2 milliliters. I added that much sodium hydroxide to 10 milliliters of HCl. So what are we going to do with those numbers? Well, the sodium hydroxide, we knew that it was 0.10 molar. But we did not know what the molarity of the HCl was. We know exactly how much of it we had, and we know how much base we used to neutralize it. So how could we calculate that concentration? Well, does this look familiar? M1V1 equals M2V2. It's the same formula you used when you did dilutions. We can use that for a strong acid, strong base titration as well. The 1s are the base and the 2s are the acid. Or the 1s are the acid and the 2s are the base. It doesn't matter. If the 1s are the acid, then M1, we don't know. That's our unknown. V1, we know is 10 milliliters. M2, well, the 2s are the base, so we know M2 is 0.1 molar. V2, we just calculated that over here. It's 36.20 milliliters. And remember, when you're using M1V1, as long as both of your volumes have the same unit, it does not necessarily have to be in liters. And so we can punch this into our calculator, and we will find that the concentration of this acid, which we didn't know to start with, is 0.362 molar.